Today we're going to be science teachers teaching to a high school classroom. So I'm Bryson Delbridge.
I'm Wade Musso.
Donovan Fagonis.
And Ashley Swearingen.
This is Operation Potato. So to start off, we're going to talk about what electricity is first, so you guys understand what the experiment is. We're going to do today with potatoes. Electricity is the energy that is formed between charged electrons and protons. So when thinking of electricity, guys, what's like the first thing that you think of with electricity?
Lights.
Lights. You guys think electricity is pretty important? Yeah. What would you do if we didn't have electricity?
Probably die.
Pretty big change, wouldn't it? Yeah, so examples of electricity, we have batteries, jumper cables, fridges, which are pretty important, I think, standardizing the whole cooling of food. We have our phones and how they can charge, toasters, which I don't recommend taking in a bathtub.
Alright, so going into our potato operation, you guys are probably wondering, like, well, how is a potato doing anything with electricity? So looking at this, potatoes are not electric, so you don't have to worry about your mashed potatoes and mixing it with your gravy, so that's good. So how does it work then? The zinc and copper from a penny and a nail, when they get stuck into your potato, they actually have a current that goes through the liquid that's in that potato. So here when we're going to do our experiment, when you cut your potato open, you'll have the two halves, and you'll put one in each, and those will connect because of that liquid. And that potato is like the conductor of all of it. So here is a little video to kind of give you a little more information.
Have you ever wondered how potatoes produce electricity? Well, I'll tell you how potatoes power your alarm clock. Potatoes are stem tubers, which means these plants developed in large stems that thicken into the tuber. These tubers are for nutrient storage, which is stored in the form of starch. Starch helps generate electricity. A tuber also has all the normal parts of a stem, and a tuber has the same structures of a stem on the inside. Raw potatoes tend to be highly acidic. An average potato has a pH of 5. pH is a scale for measuring the acidity of things. This isn't highly acidic, but it is far from neutral acidity. A potato's acidity is determined by the combination of the potato strain and the pH or the acidity of the soil where the potato was grown, and the method of storage the potato has. The acid in the potato can be used in a chemical reaction to generate electricity, just like the acid in batteries, which use chemical reactions to generate electricity. To get electricity out of the potato, you must use metal to spark the chemical reaction, like galvanized nails, which are covered in zinc, which reacts with the acid in the potato to release electrons in a chemical reaction. The active chemical reaction of the potato's acid is positively charged hydrogen. You can even see a hydrogen gas released from the potato near the nail as a byproduct. Freed electrons from the potato travel from the nail electrode through a wire to what you're trying to power, like a clock. As mentioned before, you need metal to start a chemical reaction. You need two different metals to create this chemical reaction. These metals can be zinc and tin, or copper and steel, or other choices. One metal must be positively charged to pass positive electrons. The other metal must be negatively charged to pass negative electrons. Now you know how potatoes can generate electricity. Thanks for watching.
And now we're going to bring up like a little animation to help you visualize an electric current. So,
Can you see that? Need to zoom in.
alright, so here we have an electric current you can see right up here. That kind of represents our potato giving off a voltage, and it's creating a flow of electrons, as you can see with the white dots. And then over here is representing our light, and it'll go through and light up the light and use up the voltage. And then it's all connected, so you can call it a complete circuit.
So you can picture the green side is your zinc nail, and the returning side at the top is your copper penny. You want to visualize that as we go into our experiment. Okay, so we're going to kind of rush through the beginning, just a quick introduction on why potatoes are batteries and vice versa. But we really want to get to the experiment since this is hands-on science today. So we're going to just count off and make 3 groups. We'll start here. 1,
3, 4. 1.
Oh, sorry. Am I 1?
1.
Yeah.
1, 2. 1, 2,
3.
1, 2, 3, 1, 2,
3.
1, 2, 3.
Okay, slightly. We need one more for then 3. But we'll do 1s on this side, 2's kind of in the back, and 3's over here. And we will send one gopher for the group up to pick up a bag of supplies. These are potatoes. Each group will need a minimum of 2 potatoes, which we'll cut in half. Feel free to grab an extra one. Please work on newspaper, and we brought some butter knives to chop potatoes in half. And then we'll demonstrate how to do this once everyone's back in the groups with their materials. Questions so far?
Don't use your knives as weapons, okay, guys?
Okay.
College kids. Ladies and gentlemen, you can handle it.
Okay, group 1, group 2.
Potato fetcher. Is this 2 back here?
Yeah, do you guys want
Yeah, you guys can.
somewhere more
Yeah.
with you guys? Or are you guys?
Potatoes.
Yeah.
Cool.
Okay. All right, so in your bag, and Claude is here today to assist in the demonstration. Oh, we may need newspapers. I'm going to pass those out. But we'll get started. So in your bag, you will find some wires, some nails, and pennies. You'll notice 2 of the wires are connected to a little tiny LED light bulb. And every group has newspaper, a butter knife, and potatoes. Okay, so you have all your materials, 4 pennies, 4 nails, 3 wires, 2 wires connected to an LED. Anybody need extra parts?
You know.
No. Okay, go ahead and cut your potatoes in half. Everybody grab a potato.
No, that was good. That was clean.
Yep. Claude will demonstrate. And I'll walk around and make sure we get everything in half.
Totally in half.
It's twice enough. You did
Okay, you might need different potatoes to cut them in half the other way. Let's see if
You did not specify
Okay.
which way to cut the potato.
So if there are any questions in the methods, just watch Claude. He's an expert at this. Not only an art expert, but a science buff.
Can we just like
Okay, once your
cut
potatoes
what
are
we
cut in
already
half,
have?
take the flat side and set the potatoes down on the flat side.
I don't
Kind
think
of
it's gonna
place them all in a row.
Oh my gosh.
You guys see the sunsets back there?
And you can
So did you
imagine
make it like French fries or?
potatoes, since they're not actually used as batteries, are pretty low in voltage. So these little LEDs will start to light up with 1.2 volts.
There we go.
Therefore, we need multiple potatoes in a row because each potato half generates a little less than half a volt. So we have a way to measure this once we get going. Okay, so in one side at the top of each potato, using your knife, put in a little slit carefully, just big enough to fit a penny in. So each half will have a slit to fit a penny in.
We need
And with your first penny, before we put pennies in, with your first potato, go ahead and take a wire, one of your 3 wires, and wrap the wire around the end of the penny. And then you can shove the penny and wire down into that slit.
Come on, help us.
will demonstrate.
He looks like a fly.
So wrap it so that the wire is kind of stuck on the penny, and as you push the penny into the potato, the wire stays on the penny, just like that. So push it down into the slit.
Oh gosh.
No more than 1 inch away from that, you will wrap a wire around a zinc nail now and push it into the top of the potato.
The same potato?
The same potatoes, yep. So that is the first source of electron transfer in your battery.
Is it the same?
Yep, so we'll take a new wire
Yeah.
and wrap the zinc nail and put it within 1 inch, no more than 1 inch away from that penny. And try to get the pennies as deep into the potato as possible. So if you remember the video, the acid in the potato is reacting with the penny and the nail. So the more metal down in the potato, the more electron transfer you get.
You kind of like a combination, kind of like a physics and just kind of mixture of everything.
It's okay to get closer to the nail, but when it's further apart, there's too much resistance to get electrons across the potato. Just try to shove it all the way. The more, all right, and I'll use this group real quick.
This is the same potato?
That's a great one.
I think it goes on the same potato.
So this is what your first circuit will look like. A nail with a wire, a penny with a wire. Now, the penny wire will connect to a zinc nail and go to the next potato. The zinc nail wire will connect to a penny and go to the next potato. So you'll have a row of potatoes.
I wasn't listening. I was not either.
Yep.
So what you do, I think he's going to do that again. He's going to ask my question. So you're going to make another one with your potato.
With
And you're gonna- it's gonna be like-
more
it's gonna be
wire.
like a row.
Is it going to be with this?
So
They're lost.
penny to nail, penny to nail.
Okay.
So the potato that has penny, that wire, wrap a nail on it, and then push that into the next potato.
Oh, okay.
Does anybody else want to do it?
Y'all are doing great.
I do better when I'm in
So that one has to go on a
So
different.
you'll have pennies in a row,
No.
and they'll
Right?
have wires like that.
Oh
They
gosh.
have a
Oh,
nail
God.
to a penny, a nail
Yes.
to a
Okay,
penny,
okay, good. We're good.
and so on.
That's it, I lost it. It's like you only did this twice.
Electrical.
We're doing great.
How are you gonna put a hole in the
Next potato is going to
grab another one of your nails
be over here.
and put it on that potato.
It
Just
looks
want
great.
to.
Yep. And so we can actually take, this is a multimeter. This measures all things electrical. I have it set to measure voltage. So we can actually measure this. We take 1 inch,
Oh, maybe this one has another.
1 inch,
Does it have another thing?
and we gain 0.76 volts. So we can-
This is not going to be a set.
So as you can see, you need quite a few potatoes for this.
I think the penny goes in this one.
Does a nail go in that one? Because I think maybe a nail goes in this one too.
Put the nail in.
Oh, we still have 2 of each. You're right.
So I think this one needs a
Yeah,
penny.
they should all connect.
I think that
And
one
I'll
needs
leave
a
all
penny.
this up here. We have extra wires, extra pennies, extra nails, extra potatoes. If you feel like you need more.
I feel like I need to go.
That's a little close to that. So I'm just gonna stick it.
Once you get all 4 in a row, raise your hand and we'll measure the voltage.
We need help.
Okay, we'll measure voltage real quick. And actually, if you leave these potatoes a while, it has to
He's going to come check it.
You're at
Just to make sure.
1.
I think it's.
Ow!
Touching them, I can't see.
And that's
They're not
negative.
touching
That
it.
reverse
No,
these.
I don't think so.
Okay.
It can be closer.
Okay, so these
And then I
lights
guess.
start illuminating at 1.2
That
volts,
one's last.
but they are very, very dim. So you may have to cover it with your hand. And these have polarity, so do this. Push the light one way,
It's like opening out.
and ask the light the other way. It doesn't light. So if it doesn't light at first, you might have to.
Okay, should we try it then?
So, this last step, connecting your light, is kind of a guess. You have to look at how your circuit is built.
Our circuit is That's alright. I think we just
So
put
the
it
light
in, and
is
if it
in
doesn't work,
series.
we
If you
just have
remember
to
the
flip
diagram
it.
with the electrons going around.
That's okay.
So look in your parts spec and see what else you have left. You may have to use those items if you think about how the circuit builds in
Do
stages.
you want us to cut another?
Okay, so what's oh, I see.
So that's fun.
All right. So you might have to reverse the light. You might have to cover it with your hand. They're super dim.
Yeah, but then the.
Or you may need to integrate more potatoes.
Okay,
Let's
flip
switch it first.
And I can measure the voltage too, if you want to see where we're at.
Maybe we should do that.
Sure, yeah, let's do that. How does that work?
Guys, now you have
Or not.
4 more minutes
Just flip it real
for
quick
your
and you'll check the
presentation.
voltage.
Okay.
1.5 volts. That's pretty good.
That does not want to come out.
Okay, so raise your hand if you have light.
So that.
Okay, does anybody have an idea of how to make the light brighter? It took 4 potatoes to get 1.5 volts. The LEDs will get brighter with more
You won't,
voltage.
it's not enough to.
So rather than assemble a whole bunch of new stuff, if we have 2 groups or clods set up, we can connect 8 potatoes right away and see if that's brighter. Some of them are pretty dim. We also have a little clock here if you want to try that. We may not have time for that. Okay.
Actually, guys, I'm gonna shut off the lights
It might be.
for some of you whose lights are dimmer.
It's
That's crazy.
It's not on. It's like, no.
It's so,
So you got it.
but we got it.
You might
Just
just
imagine powering a
try
high
flipping it around. On this side, you need to connect the light
Mind is an infinite energy source
to the wire.
that have to be tapped.
Put it in on the penny side, and then penny
You're welcome.
to the wire on the nail.
You're welcome.
Thank you.
I love
Nate's facts of the day.
So with the last minute or two, are there any volunteers to connect 2 of these circuits together
To make your light brighter.
to see if we can get all the brighter light?
Yeah, connect those.
Okay.
And you guys want to slide yours down here? Once these guys get theirs lit up, you can connect them. What about you guys? Did you guys get light?
Yeah.
Cool. Do you guys want to connect it too?
Sure.
You guys can go ahead and move your stuff over too.
We have
All right. Any questions? Has anybody done this before? Yeah. All right. So what are some of the factors that might lead to a brighter light versus not so bright a light with the same number of potatoes? Okay, size of potato. So more acid in larger potatoes, you get more reaction with the copper and zinc.
How much of the lighter is in the potato?
Yep, definitely how much surface area of the wires in the potato.
So do we have airs
And you remember the demonstration of the hydrogen gas coming off? So luckily nobody's smoking right now, it's highly flammable.
You guys should just use like one light and connect all the other potatoes like you did your 4.
Okay.
Yeah, and then have one light at the end.
But the spacing of the nail and the penny vary how much hydrogen gas is produced, which is your electron transfer medium. Okay, as that group gets their mega light set up, anybody have questions? No? All right. So if we quizzed you guys on how batteries work next week, everybody can pass our pop quiz. Cool, all right.
Thank you, guys.
Thank you.
So if you guys just want to throw your potato batteries in these